Hello everyone. Good morning and good evening to all our viewers from different parts of the world. Firstly, we would like to begin by thanking our viewers as we have crossed 1400 plus views. Do support us by subscribing or following us on YouTube and Facebook. Today we are back again with an interesting session entitled Transition of Fields, a Fireside Chat. In general, if we look at a particular field of study, as many of us do, there is a direct step by step path that we can take. However, there are few people who choose the leap of faith from this direct path and switch their fields of study. That is different and sometimes even alien to them. Today, we have some interesting panelists who have switched their fields of study or research. I would like to welcome Dr. Rishi Rajat from Wealthy Therapeutics and Ashwin from NUS Singapore. We would like to hear from them about their diverse backgrounds and their current field of study. So let's start with a brief background and their journey from our panelists. So can we start with Dr. Rishi?
So I am Rishi from India, and I have been I am a medical doctor. I've completed my MBBS, and after that, I completed my MTech in biomedical engineering. I completed my PhD in the development of technologies for diagnosis and treatment of neurological diseases, and then I moved on into working for clinical research in a company that deals with digital therapeutics. So my whole life has been a series of uh, uh, experiences which can take technologies from the bench to the bedside, and that's the gist of my career.
That's pretty interesting from transition from like properly from clinician to the basic science. So that too, especially from having a bench to bedside vision. So how about you, Ashwin?
Hi, I'm Ashwin. I'm from Visakhapatnam in India. I did my bachelor's and master's, which was a 5-year dual degree program, in which I did the bachelor's of engineering in mechanical engineering and my master's in physics. So once I finished that, I I spent like a couple of months teaching statistics to MA psychology students,
Mhm.
and then I came down to Singapore, and then I joined my PhD in biology. Specifically in developmental biology, we are trying to see how molecules diffuse and how these signaling molecules go in uh, and cause the developmental pathways to get triggered. So we are seeing the physical basis of how these molecules are moving. So I build microscopes, uh, do a lot of image processing, programming, and things like that.
Mhm.
So it's a good mix of physics, mechanical engineering, and trying to solve a biology problem. So that is my transition from science, the physics and the maths part to biology.
Mhm. Okay, that's pretty interesting and inspirational as well, like how you use your physics also in the biology, especially from the microscopic views as well.
Yeah.
Okay, that's interesting. So we have some questions here. Like I would like to know, like, what sort of reason is behind your decision to select a field that is somewhat alien to your previous line of work? So maybe we can start with Ashwin.
Yeah. I mean, biology was never alien, right? My parents are doctors, so my dad's a neurosurgeon, my mom is a psychologist. And even my sister is a doctor now. So the biology was never alien to me, and I've always seen I've not seen fields as physics or chemistry or biology. It's like we have given them names for easy easy studying and getting degrees. These distinctions are made by us. Uh, but having said that, uh, there was one key person in BITS uh, who who, uh, who basically she taught us general biology in first year.
Mm-hmm.
I found her really motivating and inspiring. So if you know Dr. Suman Kapoor from BITS Hyderabad, she develops diagnostic kits for glucose testing and I mean basically sugar testing and things like that. So
Okay.
she was mentoring me from my first year, and then I got really interested. And then over time, then when once I saw that there was this advertisement where they needed physics people or computer science people, so I just immediately applied. And the prof happens to be a physicist who again has also done a transition of fields from physics to biology. So it was an instant connection. So in like we had a 30-minute chat, not even an interview, and then he's like, okay, let's join. Let you can join for PhD. That was nice. So
Okay.
yeah,
That's nice.
that's it.
How about Rishi? So
Yeah,
what?
so as Ashwin said, yeah.
Yeah.
So as Ashwin said that there are no watertight compartments between these various fields that are there. So medicine in the present day is advancing in various frontiers. Biomedical engineering, drug delivery, smart biomaterials, these happen to be one part of those frontiers. And I don't think it's alien in any way. It's more of a a not yet explored area, which I found very interesting. And again, a similar story to Ashwin. My advisor also happened to be a medical doctor who later went into biomedical engineering, and there are many problems that can be addressed with basic knowledge of biomedical engineering and basic sciences, uh, which many a times becomes a bit difficult when you are in the traditional or the conventional clinical route if you follow with an MBBS and then an MD and then going into specialization. So many a times to solve various problems in medicine, you need to look at it at a different perspective. This is my way of getting a different perspective into medicine. So while alien is not a word I will choose, but yes, but it's looking into medicine from a different lens.
Okay. Okay. That's interesting. Well, yeah. Having said that, it takes guts to pursue a career in science, and even more to switch the fields midstream. Executing a disciplinary change between the PhD and postdoc appointment requires thoughtful analysis and research and due diligence. Right. So, how do you describe your transition from medical to medicine to bioengineering for you and for Rishi, for Ashwin? Like, how you like describe your journey from BTech to MSc Physics, then to biology and developmental PhD? So, what sort of like problems or what sort of like problems did you face during this transition? How did you handle them?
Nishi, you want to go? Or?
Ashwin, you can start. Maybe I'll come up.
So problems wise, basic thing is when you're studying biology, the mindset is completely different, right? For biologists and physicists, I mean, I might offend both groups of people, but physics, generally physics and even maths for that matter, has generally been more abstract and more rigorous, I would say, in the sense that uh, you expect something to happen and it has to happen, and nothing else has to happen. But when you go to biology, it's so complex and there's so many exceptions to the rule, and they're not rules as such, right? Because the things are so complicated. There's so many things interacting with each other.
Mm.
So the way in which a biologist is trained is completely different from way in which a physicist is trained, for example. So when we do our experiments, we have a set theory, we have our equations, and experiments match our equations, right? But
Mm.
in biology, they don't have any equations to start with.
Yeah.
So you have uh, a set of an experiment that you want to do, and then you do a control experiment that basically matches all the conditions that you have used, because you don't understand what these conditions are doing to your stuff. So you want to have a control set and a experiment set. So the it's a radical change of thinking also to
Mm.
begin. And here there is this first principle way of thinking, and here is a perturbative way of thinking in biology, where you like tweak small things. So to learn that, it gets hard, and it's not like I have mastered it. It's a 5 year plus 3 years of being in touch with biology has made me realize that and both fields are good in their own way.
Mhm.
uh, but at the same time, uh, when you're trying to be in the fringe zone between these two fields, you need to respect both of them for their merits, and also uh, understand that there are shortcomings in each of their ways of approaching the field, right? So take the good ideas from biology, try to use it in physics, and so that's what I've been trying to do.
Yeah.
uh, that's what I think. It's hard, but it's fun. We're learning every day. So that's the fun part.
Okay.
Rishi, yeah.
So from medicine, if you actually look at clinical medicine, there are people's lives at stake, and then when you move to this, you find the rigor behind the drugs you prescribe. You find the rigor behind even an ointment that has been developed. Uh, uh, what kind of basic knowledge that you needed to actually develop that drug.
Mm.
So there is a learning curve associated, although Ashwin had a very, I mean, his transition was much more as compared to mine. But uh, in biology or in clinical medicine, there is a learning curve involved whenever you start.
Mm.
So and it extends right from taking care of your glassware to writing papers. So
Right.
everything. At first, I believe I'm still rubbish in writing papers, but I've become better as compared to 2015.
Mhm.
So, so there is a learning curve involved, and
Mhm.
that patience you would be needing that wherein people have been doing that for about 5 or 6 years. You have to respect that, and you have to believe that someday you'll be at a position wherein uh, you will be at least good enough to perform clinical research, to perform the research in your field
Mm.
uh, as good you uh, which will be comparable to your peers and perhaps better than them.
Mm.
So it's more of the learning curve that makes these transitions interesting, but at the same time it humbles you about what kind of things exist across you, which becomes very difficult if you follow a single linear pattern in your career, wherein you start with a particular course and whatever your peers are doing, you continue to work on that. So that's the beauty of it, the learning curve.
Yeah, that's really cool and pretty interesting. Like sort of journeys, a part of journey you shared. So yeah, generally whenever you undergo a change in shift, right? So you have to demonstrate to your new colleagues and how your expertise, your previous expertise, can be an potential boon for the research group, and you have to gain an understanding of the new field and its cultural and language, right? So what questions do you suggest to students or the younger generation who should ask themselves before they switching their field? Maybe we can start with Rishi.
Anytime I found this very interesting that whenever you plan to make any change or you are faced with a dilemma, uh, the basic questions that we always ask in research work. So what, when, where, why, who. So if you consider those questions basically, especially the what and why do I want to shift from here? So there are two things. One is the push that
Mm.
whatever you are doing, maybe you're not liking it, which is very sad. But there's also a pull factor wherein you may be liking something that is totally different from your field or that is related to your field but will require a lot of hard work and many times a very low pay. So in that case, so why you are planning to change, that becomes the major part. And apart from this, if all these if you consider biomedical engineering, it comes in various shades. It's not that it's only drug delivery. It ranges from simulations to something like tissue engineering, wherein there is a totally different skill set required. So understanding the what also is important. Which part of that particular field are you interested in, and whether you will be happy with just an internship in it, or will you be ready to dedicate your life into that? So that is the what of it. And then once you have figured these out, and who and when and where will you do this particular thing. Now, the important thing here is the when of the question, wherein you have to figure out, like in my case, there are many Indian physicians who complete their PhD after they have completed a specialization. So after India works in a way in which there's an MBBS and then an MD. We don't have a direct MD in India. So many people complete their MD and then go on into PhD. So for me, it was I was very much interested in learning those drug delivery techniques, and I didn't want to wait after my MD. So the when is also important, and then you can figure out where and with whom do you want to do it. So not only the institute, but who would be an ideal advisor to make the shift. So I think the basics of the basics of any research, if we follow even in answering these dilemma questions, of course, a cliched way is to create a pros and cons table and find out. But then the issue with pros and cons is that even one pro many a times outweighs all the cons. Just you wanting to do something, that's enough motivation for you to do it all of your life. The other way also is true. One thing you don't want to do your all of your life,
Yeah.
that is enough motivation for you to stop doing.
Okay. Ashwin?
Yeah. So of course, I mean, this was much more generic. I mean, that was a really nice answer. But unfortunately for me, my thing was extremely practical, and I don't want to sound cynical also, but in physics, I mean, I'm going by very practical life things. Physics and mechanical engineering in my undergrad days were not paying enough. So the job I was not. I mean, I didn't. One for physics, there were no companies coming to even like hire. Why would you hire a physics teacher? And then even in mechanical engineering, the pay packages were like, I mean, I wouldn't even want to say that. So the pay packages were low, but I worked in a company where I've gotten 8,000 rupees per month as an intern, but they took care of everything like food and like morning, evening, night food, and the level of work and their culture of work was so good. So then I was like, this 8,000 is just a bonus, right? So it was like that. So yeah, there is passion and there is like these things, but for me it was very practical. One, in physics, people are going to the extremes of I mean, the particle physics, or in nuclear physics and other places, they have literally reached the pinnacle of what is there to be known, and so it is very hard for you to make your place there, right? And physics, and in the same way even in engineering, right? So you have to work in big teams. You're just a small atom in a big team, so you can't make. I didn't feel that we can make much of a difference there. But in biology, you have a lot more opportunities, a lot more unanswered questions, and which are lot more relevant and more practical. I'm not saying that astrophysics and all these should not be there. It should be there. It's important also. But in coming to a practical thing my training can help someone, or where I can develop something which can be useful, I thought biology was a better transition. And also for hopefully with the job scope and what I can do in the future, I think I might be in a better of place here than in the other fields. It's just that kind of a practical thing for me. And to say that the stipend that I get now is a lot more than what I would have got if I would have taken a job in the other. So I'm not trying to be disregarding of the other fields, but that was how it was.
Okay. Yeah, thanks. Thank you for your wonderful pointers. So, well, having said that, the only way to do great work is to love the work what you do. If you haven't found it yet, keep looking and don't settle. So this question, like I would like to ask to Dr. Rishi, but specifically in countries like US, UK, Europe, and Australia, like they have successful programs implemented, like MD, PhD program for physicians like you, such that they can bring their clinical knowledge to integrate to the laboratory based research work to bridge the bedside and the bench gap. So, what do you think these programs would motivate physicians to pursue transition to the research scientists or research areas? So, what sort of views do you have for this?
MD, PhD, especially if you consider in India, the issue is that, again, MD is an advanced degree. It's after MBBS, you have to think of it. So most of the MD, PhD programs are in medical colleges. They have very little technological inputs in any of the work that you do, especially for your PhD. So in that case, what happens is if you have a particular area in mind, I had drug delivery in mind. So it becomes very difficult to find a particular professor who will be working in that particular technological area and also working in clinical medicine, which is the basis, which is the gist of many MD PhD programs, wherein you train a doctor to become a physician, or to become a physician scientist. So in this case, what happens is within India, one of the basic issue is flexibility. That flexibility of choosing your field of work, which I did not get because of the fact that I had a particular thing in mind which was only available in places with a technological background, not in medical colleges. So doing an MD PhD was a bit redundant for me. Doing a PhD was much more relevant. Having said that, there are also some restrictions in terms of admission and the kind of collaboration that you can make during an MD PhD because of the patient load that most of the medical colleges have. All these factors pushed me towards a PhD rather than having an MD as well as a PhD.
Mhm.
So to sum up, it's mainly the collaboration and the flexibility of change that gets restricted if you are planning for an MD PhD. Having said that, of course, there are successful MD PhD physicians all over the country, and there are institutions that are coming up which need physicians with scientific training. So yes, things are changing, but they need there's still a lot more to do before we can have a successful MD PhD program. It depends on how well you can gel the medical education with the scientific commitment, in spite of having high patient loads, which is a problem which has not been cracked yet in India, at least.
Yeah, okay, yeah, that's a pretty nice overview of what you have. Okay, yeah, generally, like again, like for decision to change the fields is not always about personal preference. Sometimes, in some professional, it is also to do with ensure about the employability. What Ashwin said. So in India, generally, most decisions of choosing stream is made by peer or family pressure. Can you give your input, especially at the early stage of our career, like before bachelor's or even earlier? So can you give your input on how to deal with that, how you have faced that, how you have dealt with that? Rishi?
I think Ashwin will be a better
Yeah.
person to answer this first, maybe
Uh,
because he started with it.
You
So,
can,
no,
so I'll join in later.
yeah, sure.
okay. So you're asking about parents and the societal thing, right?
Yeah, not specific. Yeah, generally, like, how did you manage to like address your parents when choosing a different?
Extremely hard. So now making a transition from engineering to biology might be interesting to a lot of people, and people feel like you're very brave and all that. But then it's really hard to convince your parents. And it's okay if you can convince your mom and dad, because my mom and dad are doctors, so it's fine.
Yeah.
But it's even harder to convince your uncles and aunts. because they are like literally judging you. Like
Mm.
you're not sticking to anything. You're not an expert of anything, right? So you're neither doing physics nor you're doing biology. You're not going to be an expert in anything. You're not going to like. You're not going to be. I mean, what do I call you? Like, what are you? So it was extremely hard, and the thing. Uh, the unfortunate reason was that I was more inclined to math than biology. Doesn't mean that I was not liking biology. I could have done medicine also. I also want to do this. Even, I mean, given a chance, I can do a PhD MD if that happens. It'd be great, but I think I'm getting old for that. But the idea is, I mean, you can't in India. The unfortunate thing is, right in the 10th standard, you have to choose between medicine and engineering, and that's a hard binary yes or no, which is so hard. And at 15, you don't know anything. Like at 26, I don't know anything. I can still, I want to still make a transition now also. So, I mean, it's too hard on kids at 15 to decide, and it's hard, and maybe because parents, even at some level, my parents are also looking at other parents and seeing what these guys are doing, and then giving us suggestions, right? So uh, I really feel parents need to be a little bit more open-minded, especially in India, of course, but open-minded, and not only see medicine and engineering are not the only two fields. You need to have other fields also coming up. So I don't know if it can happen, but I really hope in like next 5 to 10 years we see more diverse set of people where uh, in US you have these curriculum where there's liberal arts coming into engineering and liberal arts going into medicine and things like that. So if we can see India going into that place, I feel we'll have a much more overall and well-rounded development in how we work and how we think. So that's what I'm hoping. It didn't happen with me so much, but I hope so. Yeah.
So,
So again, on a relevant note, if so, it's the how bad are we at arts? Maybe can be if Harish, me, and Ashwin, all the three are asked to draw a scenario, draw a scenery. Most of the cases, you will find that we'll be drawing the same scenery which we have been taught: two mountains with a
Yeah. Yeah.
with a small sun that comes up. So we have never been trained in liberal arts in any form. I mean, it's mostly copying from art that has been drawn on the board, which is not art in its all in the whole sense. But yeah, coming to parents, I was much more luckier where I was given a so every time I had to make a decision where I was in a dilemma, I was given a lot of freedom to work on it. But of course, I was also lucky in terms of my family. The issue happens mostly with neighbors and
Yeah.
the people
No,
whom
so
you don't know.
even the parents are good. You can talk them out of it. You can't talk these other people out.
Yeah,
Yeah.
the natural transition happens is you stop enjoying parties and weddings from your life because the obvious question of what do you do in your life is not that obvious to most people. So
Exactly.
when you say I'm a biomedical engineer with a training in medicine, that's something that will take up half an hour and won't help you with
Yes. Yes.
the gulab jamuns that you have in hand. So,
Yeah.
so rather than having those, rather than having those things to be explained out to people who will hardly matter ever in your life, that becomes a bit difficult. But then this particular exercise, what it makes you, which happened to me. I'm not sure if it has happened to most of you. It makes you cognizant of things that matter in life,
mm,
and those who matter, they'll always support you. So that's something that has happened ever all over my life. So it has been my parents, it has been my grandparents, it has also been most of my family and the family which I married. So they have always been supportive of the fact, and they are the only people who matter. So that's the part. That's the best thing about transitioning fields. You actually can filter out people who are irrelevant to your life. So yeah, that's what's my take on it.
You also, the other good thing is you're getting to meet people of different fields, right? You're getting to mix and socialize. and you're getting to talk to these people and their perspective, your perspective. It's like you're getting so much more out of life than just if you were only in one field. So I genuinely feel it's well worth the half an hour explanations over gulab jamuns. Yeah.
Yeah.
So, one of the things that I generally say is in a class of about 23 or 25, we were taught about action potentials, which is a very basic concept that is taught in first year of medical training. Now, to look at it from an engineer's perspective, it's like you're learning that all together. It's actually you're learning it once again. So it's something that you never believed that it can be explained from another perspective. We knew that it has to be certain ions that are going in, certain ions that are going out, but there's an electrical component to it, and which also makes sense. So to figure out things that make sense from a different perspective is itself very interesting. It's something that if you are again in a conventional route, you will never be able to meet those people or understand those ideas.
Mm.
I totally
So
agree.
that's something that I find interesting.
Thanks for your feedback on that. As you adjust to the new discipline, there will be many challenges to be met. One of the major difference in any field is how the experts think about problem solving. Each field has its own research approaches which you have to learn quickly when transitioning areas happen, right? So what are the benefits you have found, and when you start a different field of expertise from your previous line of work? So what sort of pros and cons did you face when changing the route of your career? So maybe I can start with Ashwin.
Yeah. For me, the lot of pros and the equally a lot of cons. So pros wise, I for some my prof in my undergrad, they knew that I was a very good experimentalist. So that rigor and that experimental aptitude continued into my PhD, and so that helped. And a lot of ideas coming in. It's easier for me to make a transition and
Mhm.
understand things and learn things, build things up. So that was good. The rigor came in, and then the quantitative way of looking at things came in. But what there was another stubbornness with coming with the rigor. There is a lot of stubbornness that comes. You don't like to listen to things which other people tell you. Because so for example, let's say I'm asking someone how this uh, protocol works, or how do you make a particular set of molecular reactions, right? They would just say add this, and then I'm like, okay, so why is this happening? But no, I go look at the kit, and then the kit also does not have enough. It's just like add two three reagents. So it gets a bit frustrating that people in biology, of course, they are looking at a big picture thing. Their mindset is completely different, and as a physicist, I'm looking at the small details. So we are never talking in the same wavelength. So you need both. You need a big picture kind of a thing. How does my work help in saving a patient's life? It will happen sometime or the other, but how does it go to cancer, and how does it help in tissue engineering, for example? My developmental biology work somewhat would go into understanding how we can develop and engineer tissues, right? So this big picture perspective is coming from the biologist. They do not actually care about the nitty gritty details about atoms and molecules and all. They don't care, and they don't care about the math, right? For them, what works is their experiment and their controls and their the certain test case that they're looking at. And
Mhm.
so for them, that is their limit. And for us, we are being too rigorous. So it's hard to go from math to, so in the sense that from a physicist or a mathematician can make a transition to biology. If my physics can go into chemistry or biology, biologist going to physics will be even harder, right? Because there's a completely different set of training that you need, which a biologist would not get. A quantitative way of thinking, the equations and things like that. So uh, it's easy to go from a more abstract to a less abstract class of fields. It doesn't mean it's abstract, doesn't mean it's easy or hard. Both of them are hard in their own way, but the trainings are completely different. So you need to learn, you need to pick them up. So that takes a lot of time, and I hope I'm almost there. Going to get my PhD soon, so I hope I'm there. But I know I'll not be to that level as we would all expect to be. Yeah.
Okay.
I face an issue that's diametrically opposite to what Ashwin faces. So I come from a background wherein I don't mind whether which atom is reacting with what and what kind of characterization technique I need. I
Yeah,
mind it
biology.
when it comes out into the market. So again, so I am at the fag end of that biology, wherein I am considering more important the results that come out of the experiment rather than why it happened and how it happened. So in medicine, it's more of whether the technology will be helpful to the person or not.
Yes.
Give me a sensitivity, give me a specificity of that. That's the final clinical verdict I need. So what happens is that when you come to this day is that come into biomedical engineering or some of the basic sciences is that most of my papers they get stuck in a place wherein you don't have enough characterization data, which is needed for these particular developments in smart materials or bionanotechnology, wherein you have to characterize in a particular format. But I actually remembering the days in PhD and also in MTech, it was very boring for me to go into characterization. The part wherein you actually think of how this works on a preclinical trial on an animal model, it was much more interesting. The part wherein you do clinical trials on sensors, wherein you actually figure out whether you can actually detect and at what cutoff you can detect a particular analyte. I can see that. I mean, being used in clinics and being used in labs. So that's what mattered me more. When I look at my nanoparticles under an electron microscope or looking at cellular uptake under a confocal microscope, that is something it's far off from the clinics, and I struggled with the kind of relevance of that in clinical medicine. But over the period of time, I have come to realize that well, it's not the whole, it's even each and every part matters, and the rigor with which you do each and every part, like Ashwin said, right to the level of the atoms, of the reactions that are involved in each of your tests. The more aware you are of those, the better science that is there that you can develop, and the better, and there's a better chance that if at all something fails in the clinics, you know where it may have gone wrong.
Mm-hmm. Yeah.
Just a
So that
small,
humbling experience came with this thing. Yeah, sorry,
just,
Ashwin, yes.
just to briefly say, we have different expectations, right? If a mathematician, physicist, chemist, biologist, medical, the doctor in the clinic, everybody has different expectations from this particular piece of work. So even if you are sending a paper to Nature, there are three reviewers with completely different backgrounds, and one accepts it, one says that this is good for nothing, and then in someone in the middle who is like, yeah, what can I do about this? So interdisciplinary work is hard to start, but it's fun. So I mean, it's good. You learn a lot.
I second that. I second that. And yeah,
You
sure.
learn a lot.
That's the truth.
Certainly, we agree with that. So, yeah. So generally, for researchers, we have fortitude to start over a new discipline. Thriving and survival in the field would be challenging to lead a career, right? So, it would be interesting to know from you both what sort of steps or consideration to be kept in mind when to thrive when you switch the fields. There can be plenty of drawbacks or even the lag phase when you start a new field. So how did you sort of like adjust to the new area? How do you begin to sort of adjust to the new area? Maybe again we can start with Ashwin.
I mean, adjust as in what sense? Like
Yeah, sort of like how when you start a new switch, when you switch the field, when
first
you start a new
day.
field, like how did you cope up with the new environment of the new field, or sort of like how did you adjust to from your previous field, you know?
uh, So whenever you join any group or an organization, you need that there is a learning curve. So the first few days are hard. Then you're like, why am I here? What am I doing? But to a point where you get that stable state, right, where your your previous day and your next day are going to be almost the same. So that depends on how big a transition are you making, right? So when I went from a engineering college to an industry of mechanical engineering, it took me 2 months. Right,
Mm.
2 months I was like everybody knew me. I knew everybody. But in biology, it took me 2 years. Because it's just that getting the hang of doing experiments the right way and
Mm.
being rigorous, and then having all these exams and qualifying steps and presentations and things like that. So the learning curve was longer. I mean, people said. Uh, I don't know if I'm going to go from here to, let's say, poetry. I mean, I'm just making it up. It's going to be even longer, right? So I don't know, and it's not the time you take. It is the interest that you have and your passion. Like you like it a lot and you want to do it, you will do it, right? If it takes you 10 years, you will sit for the 10 years and do it. And I've been lucky. My parents are pretty well settled, and they're very nice to support me. So I'm able to do these things. I know for a lot of people they can't do it. So I'm thankful in that way that I can do these experiment and try out different fields. And yeah, the settling thing should not be the scary part.
Mm.
The scary part is, are you liking it, and are you improving? Are you improving daily? Which I feel even now at my fourth year, I'm still trying to improve. So I'm going there. So that is the fun part. The journey is good. I like the journey. So that is fun. Yeah. Rishi.
So for me, of course, again, the learning curve starts from washing of glassware. So I was bad at even that. So, but then there will be some people who will make fun of you after that, and there'll be some people who will be supporting you. uh, there's a family that supports you all through, and there'll be friends who will be with you no matter what. How bad are you uh, in let's say a new field will be the last of their concerns. So it was depending on these people that I could go get along, and the proof is in the fact that I could complete a PhD, and I think there are people who will be supporting you along the way. It's important that you continue to hold them close, and there will be people who will be having who will be antagonistic to you in every possible way. But I think that number should be much lesser in your life, and only then it will be a successful thing. But yes, there will be a learning curve involved. It only matters how many people will support you during that learning curve. Once you have crossed it, you'll be good as any others in that particular field.
I just had one point to add.
So,
It's also your team that is around you. Like I should shout and give a shout out to my all the places I worked. The people they were so supportive. It's again, you have to be very lucky to get that. And my lab, I mean, I've gone and asked stupidest of questions, and people have been patient enough to answer. And like how do I use a pH meter? Those stupid things, right? And how
I've
do
been
you
there, so it's not stupid. I've asked those same questions,
So
and
why is my
my lab
point
mates
not?
were equal.
Why am I getting airdrops here? And how do I load this gel? So
mm.
I mean, even like in my fourth year, I was asking like stupid questions. Other people think, like, is he really in fourth year? Does he really even know mall bio? But I think after that small little of judgment, people are nice and helpful. and that's what matters. So don't be afraid to ask these questions. Don't be scared.
Mhm.
And after that small question, that silly question you ask, you've learned more. Right?
Yeah.
So that is enough, right? So you have that stupid question, however badly they might have judged you, they have given the answer, and you now know. So those things build up, and then you're there. So I really love my team, whoever have I worked with. They've been really nice, and I guess even Rishi and Harish, I hope you would have had good teams also helping you.
Yes, yes. We agree with that.
Yeah, I had questions like I never had seen a micropipette, and I have never worked with pH meters. I have never seen those things, and because I came in from a totally different background. But uh, over a period of time, I developed friends, teammates who could support me unconditionally. It's not that you do this, then I need a particular acknowledgement in your paper. They have not done it for a small name in the paper. They have done it because they understand my cause. They are interested in the spirit of collaboration, and they want to improve the kind of environment in the lab. They want to improve from how the lab was when they entered and how they are going to leave the lab when they are leaving. So I was very fortunate to work with some people who were who were of this idea that you need to develop a lab in a way that it's not only the clinical publications or the scientific publications become better, but also the people's experiences become better, so that it becomes an inclusive lab takes into account which takes into account a people's background, but also respects them for what they add to the team. So yeah, which again shows the transition of fields wherein such experiences are possible. But it's also it also comes with a warning that you will be hitting the wall for a number of times, and then you will be finding people who will be very much who you'll cherish all through your life. So
Yes.
that happened with my team
Mm.
also.
I
And
think
you'll
like
find the right people, as you said, right? You'll
yeah.
find who's gonna stay.
Yeah,
I think in
yeah,
short, like we can say them they are the good resources which we can depend on them when we transition the field, right?
Sure, yeah.
right.
Okay, well, thank you for your adding so much of value and sharing your story and learnings. Hopefully, it will be helpful for our viewers. Before we end the session, we have an sort of last question. What sort of recommendation would you say for our viewers or anyone who are thinking to switch their fields of study? So, what to recommend for them to take care of? Uh, we can start with Ashwin.
Yeah, I mean, just have an open mind. Ask as many questions as you can. Have as many ideas as you can. Uh, I mean, it's you have this. I mean, you have it. I mean, I'm being a bit philosophical. I don't want to be too much. I'm not preaching anything, but you have this one life, and you have so many things to like learn and experience. And it's. I mean, coming from India to Singapore, that was like complete. Like, wow, this is a completely new place, right? So you can only know. So you can't know things that you don't know. You need to if you open up new doors, and then you open and then you like there's so many things in this world that you can see. Just have an open mind. Don't close your door. Don't say that I don't want to learn maths. I don't want to learn this because it's scary or it's hard. Biology is too dirty and I don't want to do it. So don't have preconceived notion. Don't just go for it. And you have like infinite potential, right? You have finite time, but you have infinite potential to do and learn and ask people, and you have internet now, so there's so many things that you can do. It's just the patience and the willingness for you to do it. And I really wish more people get to experience what I'm experiencing when I'm making these transitional fields. And 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 I'm, I'm, I, can, I can bet that they'll enjoy it a lot more than just having a linear field. So yeah, that's what I want to say. Just try it and you like it. Yeah.
You see?
Yeah, so from my experience, I would say that one of the biggest fears we have is, will we stop being who we are? It's not the case. You will continue to become, you will continue to grow on the basis of what you were already. So you won't stop becoming a doctor. You won't stop becoming a dentist. You won't stop being a physicist. What you are trying to do is you're trying to use that particular expertise that you have developed in your undergraduate or in your master's or in your PhD. And then when you're transitioning, you're using that expertise for something that you believe in, something that you love, something that you have a passion about. So that's one of the biggest fears. If at all I change my field, will I stop being a doctor? It's that's not the question. Sorry.
You're saying about the identity of
Ashwin,
the person, right?
yeah. So the issue is that that becomes a stumbling block why most people don't do this. So understand this, that you will continue to become who you are. It's just you are trying to do this for a particular cause. You are trying to explore a particular question that you have, and then you can then the answers are much more easier as to whether I need just an internship or just a YouTube video to quench that thirst, or whether I need to do a postdoc, or whether I need to do a complete graduate study. Uh, and even after that, again, this stumbling block will keep coming again and again whenever we are planning to explore a new field. But know this, that you will continue to become better while not losing what you already are. So that will enhance more number of people to explore fields that have not been explored because of a traditional mindset. So know that you will continue to remain, but just whatever happens, be happy. So if you're not happy with anything, stop doing that. That's the only thing that must drive you. That's, I think, again, going philosophical, but if you're not happy, it doesn't matter. Uh, so that's how I would like to tell that this is my recommendation that I would give to
Thank you.
future explorers.
Thank you for sharing your views and recommendation. So here we end our today's session. So thank you viewers for viewing us. So feel free to reach us if you have any question. We can answer you. So you can follow us on Facebook or even subscribe to our YouTube channel. Thank you everyone.